All right, so in this review, I'm going to quickly go over a few of the topics that are on the final. Topics I'm going to take a look at are trig functions, basically what the definitions are, how to use them to solve a triangle, how to change between radians and degrees, which that'll be a separate question, and also how to do inverse trig. Trig functions. Okay, so for the final, one thing you'd want to know is the definitions of the 6 trig functions. So we have sine, cosine, tangent, and then the reciprocals of them, which are what you get when you flip them. Cosecant, secant, cotangent. All of these definitions are going to involve 2 out of 3 of the following words: opposite, adjacent, and hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the 3 on the right, you just take the 3 on the left and flip them. So hypotenuse over opposite. Hypotenuse over adjacent, and adjacent over opposite. Okay, so those are the 6 basic trig functions written in terms of opposite, adjacent, and hypotenuse. Now, if you're not sure what an opposite and adjacent mean, when you have a triangle, the hypotenuse is always across from the 90. Theta is an angle somewhere in the triangle. Doesn't matter where you put it. Opposite is always the side that's across. So if I put it in the lower right, this is opposite because it's the farthest away. Adjacent means it's right next to it. Okay? So everything is from the perspective of where you put theta. Okay? The angle that you're talking about in your problem. So where we would use those definitions, in particular these 3, is to solve a triangle. Okay, so let's look at an example. Okay, so when we're solving a triangle, there's 2 cases. They can either start you off with a side and an angle, or they can start you off with a side and a side. If we want to take a look at inverse trig in this problem, then I need to start you off with a side and a side. Giving you a side and an angle, you'd never use inverse trig. So let me give you a side and a side. So let's go 2, 3. All right, so first thing I usually do once I have my diagram is make a table. ABC will represent the 3 sides. Alpha, beta, and the right angle will be my 3 angles. Now, for the right angle, there's nothing to find. We already know it's 90. In this diagram, which side is A and B doesn't matter. Okay. I'm going to call this side A. I'll call this side B. And that means this side is C. So A is 2. B is 3. C, I don't know, so I'm going to put a box around it because I have to find it. Alpha, I don't know it, but I know that it's across from A because that's always how you set up a right triangle diagram. A goes across from alpha. B goes across from beta. Okay. And we don't know either one of those. All right, so we have to find alpha, beta, and C. Does not matter what order you do it in. I'm going to start with C. So anytime you know 2 out of 3 sides in a right triangle, you can use Pythagorean Theorem to get the 3rd side. So let's start with that. A squared plus B squared equals C squared. Okay, so there's your Pythagorean Theorem. We're going to use that to find C. Fill in what you know for A and B and solve for C. A is 2, B is 3. 2 squared plus 3 squared equals C squared. 2 squared is 4. 3 squared gives me 9. Add them up. 4 plus 9 gives me 13. And the last step to get C by itself is to take the square root. And usually when we do these kind of problems, you do simplify it down to a decimal. So let's take the square root of 13. We get about 3.61. Okay, so now we've got C. C is the hypotenuse. It should always be the biggest side, and it did come out as the biggest side here, so that's good. Now, I would not use C to do anything else, because if C is wrong, and you use it to find alpha, now alpha is wrong. And if C is wrong, and you use it to find beta, now beta is wrong. So in order to find alpha and beta, I'm going to use the two sides I was given. 2 and 3. First angle I'm going to solve for is alpha. So now is where these trig functions are going to come in. Alpha, 2, and 3. Those are the three things I'm using. This is opposite because it's the side furthest away. 3 is adjacent. So if I want to find alpha, I need a trig function that involves opposite and adjacent. Now, if you go back, you might notice there's two of them, tangent and cotangent. When we're solving a right triangle, you only use one of the three in the box because that's what you have buttons for on your calculator. So, let's use tangent. And we are going to find alpha. So, we start off with tangent alpha equals, and now fill in the definition. Opposite over adjacent. Opposite is 2, adjacent is 3. Okay. So now the goal is to get this by itself, alpha. When you have a variable in a trig function, only way you can get the variable by itself is to use inverse trig. So what we're going to do here is take the inverse trig of both sides, inverse tangent. Take the inverse tangent of what's on the left. Take the inverse tangent of what's on the right. Inverse tangent and tangent cancel each other out. And we get alpha equals inverse tangent of 2/3. Okay, next thing is you have to know how to type that in on a calculator. If this is a multiple choice question on the final, you need to check the answers and see, are they in radians, are they in degrees? You'll know which one they are because if you see the little circles on the multiple choice, you know they're degrees. If you don't, you know it's a radian. So, I'm going to do it in degrees. So go to degrees. Second, inverse tangent, 2/3, and that gives me an angle of 33.69. Now, what I could do if I was running out of time and I had to get this question done on the final is I could hope I got alpha right and just subtract it from 90, and that should be beta, okay? Because all the angles have to add up to 180. Okay. So if I take 90 minus 33.69, beta should be 56.31. I'm just going to write that off to the side. If I have enough time, I will find beta the same way I found alpha. So that way, if I made a mistake, my mistake won't mess up two things at the same time. So, now let's focus on what's in red. 2, 3, that's what was given, and beta. Okay, so again, I'm using the same two sides, but the names are going to switch. The reason the names switch is because you switched your perspective. It's like left and right. If you turn which way you're facing, left and right changes. If you switch where you're standing in this triangle, now we're standing at beta, this is opposite. And now that is adjacent. So to find beta, it's the same trig function again, tangent. Okay. So let's find beta. So the tangent of our angle, now fill in opposite over adjacent. This time, opposite is 3, adjacent is 2. Same thing we did last time. Take the inverse tangent of each side. Inverse tan cancels out regular tangent. Inverse tangent. And we're going to type in inverse tangent of 3 over 2. Now let's scroll back up. It should come out to 56.31. Let's try it and see. So second inverse tangent, 3 over 2, 56.31. Since I got the same answer doing it 2 different ways, that pretty much guarantees that I did it correct. Okay, so that covers the trig functions and all the definitions. How to solve a right triangle if you're given 2 sides, and inverse trig, because that's what you had to use to solve this triangle. You had to use inverse trig. So the last thing, kind of a separate topic, is how to convert between radians, degrees, and radians. I think we did this probably the second day of class. All right. So degrees to radians. There are 2 steps to change between degrees and radians. So, step 1 is to multiply by pi. Step 2, divide by 180. That's how you change from degrees to radians. If you want to go radians to degrees, you basically gotta just switch what you multiply and divide by. Radian to degrees, step 1 would be multiply by 180. And step 2 would be divide by pi. Okay, and I'll do 2 examples of each. One where we leave it as an exact answer, and one where we round it. Okay. So you know what, let me do right next to the boxes. So change degrees to radians. 30 degrees. Okay. To change to radians, it says step 1, multiply by pi. Step 2, divide by 180. So you can multiply straight across, or you can reduce first. Okay, you're going to have to reduce eventually, so I usually do that up front. 30 goes into itself once. 30 goes into 180 6 times. So the final answer here is pi over 6. You do not need to put RAD. Okay, whenever you have something in radians, if you don't put a label on it, that's how we know it's radians. All right, let's do one where we round it off. Usually, if you have an angle that's not a multiple of 30 or 45, that's when they're just going to say round it to 2 or 3 decimal places. Okay, same steps. Times pi, divide by 180. Now, make sure when you type that in, do not use 3.14 for pi. Use the pi button. So 48 times pi, that's the first step, divided by 180. So 48 degrees is about 0.84 radians. Okay. And that's how we change degrees to radians. All right, last 2, I'll do it the other way. Okay, I'll change radians to degrees. So let's start with pi over 2. Step 1, multiply by 180. Step 2, divide by pi. Okay. Pi's cancel out. 2 goes into itself once. 2 goes into 180 90 times. And that means pi over 2 radians is equivalent to 90 degrees. Last one I'll do, we'll have a, we'll just write it as a decimal. Let's take 3 radians. So convert that to degrees. Multiply by 180. Divide by pi. Now, this time I'll show you what happens if you don't use the pi button. 3 times 180 gives you 540, divided by 3.14. So if you don't use the pi button, that's what you get. Now, let's take and use the pi button. 540 divided by pi. 171.89. Right? There's a pretty big difference between 0.97 and 0.89. It's not like 0.89 and 0.88. That'd be kind of close. But that's why it's important to use the pi button. So 171.89 degrees. Okay. That is how you change from radians to degrees. Right, so let's take a look at another topic, arc length. Okay. In order to do arc length, you need a formula. And the formula is S equals R theta. S is your arc length. R is a radius. Theta is an angle. But it has to be in radians. So if they give you a problem, and the angle is in degrees, the first thing you have to do is change to radians the way I just showed you. Okay, idea behind this formula, I will give you 2 out of 3 of those letters, and you will solve for the third one. So let's say you had an arc length of 12, let's say like 12 feet. You have an arc length of 12 feet. And you have an angle of 30 degrees. Find the radius. Right, so visually, this is basically what we're doing. We've got a circle. Inside the circle, we have an angle that's 30 degrees. So maybe about like that. 30 degrees. The length of the arc in green is 12 feet. I want you to find the length of the radius in blue. Right? So first thing we have to do here is the angle is not in radians. So you have to change 30 degrees to radians. I actually just did that problem here. 30 degrees is pi over 6. Now we're ready to use that and that in our formula. So S equals R theta. S equals R times theta. Okay. So now we get R by itself. Whenever you have a variable with a fraction next to it, just like if you had, like from algebra 1, 2/3 x equals 12, the way you get rid of the 2 and the 3 at the same time is to multiply by the reciprocal. 3 over 2, 3 over 2. That cancels all of that out. And then you could finish that up and get your answer. We're going to do exactly the same thing here. Multiply both sides by the reciprocal. 6 over pi, 6 over pi. Pi in the top, pi in the bottom. 6 in the top, 6 in the bottom. So now you have R equals. 6 times 12 is going to give me 72. Divided by pi. And now I need a label on that. Look at what we solved for. We solved for R. R is the radius. That's a measurement of length. In this problem, my length units were feet. So the answer to this is 72 over pi feet. Or if they wanted a decimal, that's approximately 72 over pi, 22.92 feet. And that's how you find arc. All right, so if you wanted to convert between polar and rectangular. All right, so polar coordinates are written with a radius and an angle. In rectangular, which is how we're used to doing them, it's an x and a y. So if you want to convert polar to rectangular, you have to get rid of the r, and you have to get rid of the theta. So in rectangular, there's two formulas you need, one for x, one for y. X is r cosine theta, and y is r sine theta. Those are the two formulas that you use in converting polar to rectangular. If you want to convert the other way, rectangular to polar, they would give you an x and a y, and now you have to figure out the radius and the angle. The radius, that's pretty straightforward. You use the Pythagorean Theorem. R squared equals x squared plus y squared. Okay. X and y are like two sides of a triangle. R is the hypotenuse of the triangle. Theta, it's the inverse tangent of y over x if you're in certain quadrants. So if you're in quadrants 1 and 4, your angle is found by doing the inverse tangent of y over x. If you're in quadrants 2 and 3, that's part of the formula. It's the inverse tangent of y over x, but you have to add 180 to that if you're in degrees. If you're working in radians, you would add pi. So those are the formulas that you use to convert from rectangular to polar. And I'll do one example of that. Okay, so polar to rectangular. 4, 50 degrees. That is a point in polar. Okay, to change to rectangular. That's r, that's theta. X is going to be r cosine theta. Y is going to equal r sine theta. And we have to do those out. So let's take a look. 4 cosine 50 degrees. 2.57. So that's the x. And the y. 4 sine 50. 3.06. And that's how you change polar to rectangular. Okay, rectangular to polar. All right, they would start you off with a rectangular, an x and a y value, like 2, 5. All right, so that's 2 is x, 5 is y. First thing we have to do is find the radius. R squared equals x squared plus y squared. R squared, x squared plus y squared. So 2 squared is 4, 5 squared is 25. Add up 4 and 5, you get 29. And the radius, I'm just going to leave it as the square root of 29. So that's the number that's going to go here. Now I need the angle. So for the angle, it says look at which quadrant you're in. Quadrant 1, 2, 3, 4. Each quadrant has its own formula. Now, one thing I should mention, if this doesn't cover all places you could be. Instead of being in a quadrant, you could be on an axis. If you're on an axis, you'll know right away because one of your values will be 0 in the coordinate. 0 comma something, or something comma 0. If you have a 0, these formulas for quadrants 1, 2, 3, and 4 will not work. You just have to memorize that this is 0, over here is 90, over here is 180, and if you're down there, that's 270. Okay, so you just have to memorize those 4, or put it on your record. But our coordinate does not have a 0 in it, so it is not on an axis. The point 25 is up there in quadrant 1. That's 1, 2, 3, 4. So, because we're in quadrant 1, it says to use the formula inverse tangent y over x. This is what we just practiced when we were solving a right triangle. All right, y is 5, x is 2. So my angle is approximately 68.20 degrees. Okay, so we've got our radius, we've got our angle. Just write it as a coordinate for your final answer. Square root 29, comma, 68.20. So that's how you change from rectangular to polar, and the one above it was polar to rectangular. Okay, let's look at how to find amplitude. You know what? Let's do period as well, given an equation. Okay, let's say you're given y equals 2 sine 3x plus pi minus 4. Okay. There's 4 transformations happening there. There's a phase shift, which has nothing to do with amplitude or period at all. There's a 3, which is a period change. That has everything to do with the period. That number is very important. 2 is an amplitude change. That number is very important for the amplitude. And this -4 is a vertical shift, which has nothing to do with either the amplitude or the period. So, to find amplitude, it's always the absolute value of the number in front, because amplitude is a height. If you want to look at it visually, the distance from here to here, that's the amplitude. It's the height of the wave, which is symmetrical to how low it goes as well. Okay, so absolute value of the number in front, in this case, is 2. If I made that a negative, it would affect how you draw it. It would cause a flip, but that negative would have no effect on the amplitude. It's still 2. Your graph would basically go from looking like that to now looking like that. It would flip over, but it would still go just as high as it did before. On the period. The formula for the period is 2 pi over b. What's b? That's b. I think when we did our notes, I gave letters to each one of those. I called this one A, that one B, that one C, and that one D. So, to find the period, in this problem, it would be 2 pi divided by 3. And that's the period, or we also call that the cycle length of the function. Cycle length is the amount of time it takes for the function to go up, down, and then back to where it started. Yep.
Does that pi symbol have to do anything with the phase shift that you just wrote?
No. Nope. This formula 2 pi over b is always the formula that you use when you want to find the period. Yep. That's just the formula you use. Just in case there's any confusion about what each one of these means, phase shift simply means left and right. It's a horizontal shift, left or to the right. A period change is a stretch or compression along the x-axis. Stretching and compressing along the x-axis. An amplitude change is a stretch or compression along the y-axis. And a vertical shift is movement up or down. In that case, that one would be down 4.